So we were talking about this new groups of solutes we call acids and bases. Acids are covalent compounds that when you mix with water produce the H plus ions. We call these ions protons. And then bases are compounds that produce hydroxide ions when dissolved in water. And we know that it's called hydroxide based on our study of those nomenclature of polyatomic ions some time ago. Now, the reason why they're categorized in their own group is because they have a specific way of reacting with other compounds as well as with each other. Before we can talk about those reactions, the first thing is we need to just think about the categories of strong and weak versions of these compounds. So strong acids are acids that produce a lot of proton when they're dissolved in water. In fact, we say they produce so much that they dissociate completely. As a reminder, this is what an acid look like when they're dissolved. So if I take acids that has these proton and the green anion here, and I have a bunch of these guys around, and I put water in it, a strong acid would just completely break apart into these two separate ions. A weak acid, on the other hand, may have some of them broken apart, but then the majority will still stay together like this. So that's the difference between the strong and the weak version of acids. Strong and weak bases pretty much are the same, except that now we're talking about hydroxide ion or OH-. So strong bases would produce a lot of hydroxide ion. Weak bases would produce very few hydroxide ion when dissolved in water. This table provides a small sample of strong acids and base and weak acids and base so that you're aware of what they are. I would say particularly for the strong acid, you want to memorize this because there's 6 of them, and then the rest of all the other acids you'll see are weak. A key way to know that you're dealing with acids is that the formula always starts with an H and then it follows some kind of an ion afterwards. It could be a polyatomic ion like this, ClO4, or it could just be a monatomic ion like iodide. Strong bases, you see OH as part of the formula, which is the hydroxide. Weak bases are the hardest one to recognize, and at this point in this class I don't really need you to do that, but you do want to recognize the strong and the weak of the acids, and again you know that by looking at the H and then memorizing all the strong ones. The ones that are not strong are automatically categorized as weak. Acids have their own way of naming. It's not the same as the ionic or covalent compound naming that we've learned in the previous chapter, so we're going to have to learn them here. So there's 2 types of acids that you might have. You might have acids with oxygen, and you might have acids that don't have oxygen. You're going to have to name them differently. So we'll start with the one that doesn't have oxygen, because that's a little easier. That one is often called binary acids. The way you name them is you would start with the word hydro, and then you would use the suffix IC or ic, and then you'll add the word acid at the end. So hydro something ic acid. That's the name of the acids without oxygens. The acids with oxygens, there's sort of 2 different types. This type of acids exists because it's H that's combined with some type of polyatomic ion. Now, if you recall the names of polyatomic ions, some of them ends in ITE, like sulfite or nitrite. Some of them ends in ATE, like sulfate or nitrate or carbonate, for example. So when the anion names ends in ITE, the way you name the acid is just change the name of the anion to N in OUS, and then have it add acid to the name. Whereas if the anion ends with ATE, you use the name of the anion, end it in IC, and then add acid to the last part of the name. The acid naming is really the critical one. The base name is just using ionic compound naming. Remember that you have hydroxides at the end, so that's how you would name bases. But let's take a look at some strong acids. We're going to use both the acid that doesn't have oxygen and acid that has oxygen. So for example, if you have HBr that doesn't have oxygen in it, and the rule said hydro suffix IC at the word acid. So you would say hydro, this is bromine, it becomes bromic. So hydrobromic acid would be the name of HBr as an acid. Here's HNO3 that contains oxygen in the formula. So you'd have to figure out which polyatomic ion ending that has. Since you memorize your polyatomic ion, remember that NO3 minus is called nitrate, which ends in ATE. The name of the acid would just be change that name of the polyatomic ion to ending in IC acid. So it will be nitric acid. I'll go to the weak acid here. Here's a no oxygen containing acid, HCN. The Cn minus ion, the polyatomic ion, is actually called cyanide. So in this case, we would just say hydrocyanic acid. Here's one that has oxygen in it. In comparison to the earlier one, HNO3, this is HNO2, and we remember NO2 minus is nitrite. So therefore, this one would be called nitrous acid. We can just take a look at something like LiOH here. That would just be called lithium hydroxide. And that's the name of an ionic compound, so it's not anything new. It's something we've learned before. Another important property of an acid-base solution is its pH. And the reason this matters to us is because the concentration of the hydrogen ion, or H+, which is written with the bracket like this, that means concentration of H+, determines how reactive that acid or base solution will be. So for example, if I spill a strong acid on my skin, that could have a very dangerous effect compared to spilling a weaker acid on my skin. So for example, a strong acid would be something like battery acid, which is never something you want to spill anywhere near your body. Whereas a weak acid would be something like lemon juice, for example. You can have lemon juice on your hand, it's not gonna hurt you. The way we calculate it is we take the negative of the logarithm of the H+ concentration. So I'm going to do a few examples later on to show you how to do this on your calculator. But before we do that, I just want to point out the importance of pH. As I said earlier, different pHs tell you different quantities of acids and base that are present. And this matters greatly, for example, in biological system. Different tissues and organs in your body need specific pH for it to work properly, just the same as it needs specific temperatures. So when you have a fever and you have different temperature of the body, things don't work as well. Same thing here, if you have different pHs, then some of the bodily functions would not work as well as it should be. pH also affects how fast things can happen and what kind of products are produced in chemical reactions. And then in the environmental sense, when you change pH, you might have pollution. A lot of those gases we talked about in a prior chapter that pollute air, they are acidic gases. So when they combine with water in the clouds, they produce acid rain, which causes huge amounts of structural damage to things that are made out of metals and other materials. Even when we do things like recycling or treat waterways and so on, we need to make sure that the pH is controlled, because so many chemical reactions depends on having the correct pH value. So let's take a look a little bit on how to do the pH calculation. You need a function in your calculator that is called the logarithm, or log. And there's usually a key in your calculator. This is a typical scientific calculator that we use in the chemistry class. You can see that there is a key here that's called the log key. So logarithms are just the inverse function to exponents. So an exponent is something like this. If I have a number and I raise it to a certain power, so b to the power of x, I get another number, right? So for example, 2 to the power of 3 is equal to 8, or 10 to the power of 2 is equal to 100. The log is just taking the same three numbers, but then rearranging them. So when we say the log of base b of the number y, that should equal x. It's a lot easier if you see it in an example. As I said earlier, 10 to the power of 2 is equal to 100. So now I can say the log of base 10 of the number 100 should equal 2. Answer that you get in the log is the exponent of the base number. Now, as we learned earlier, the pH scale is defined as the negative log of H+. So all you need to do when you're asked to calculate pH is the following. First, enter the value of H+ that you're given. And then afterwards, you're going to press the log button after you enter the correct scientific notation. Now, once you get that, that's just the log of the H+. You're going to need to multiply it by -1 in order to get the pH value. So you can also be asked to calculate the H+ concentration. Given the pH value, this is what you're going to do. First, you're going to multiply the pH by -1, and then you're going to press the second, or sometimes in other calculators it would say inverse, INV. Press that and then the log button on your calculator. This will do the inverse operation, and I said earlier, log and exponential are inversely related. This will just raise that number that you just multiply with -1, 10 to the power of that number. And then whatever number you show on your calculator, that would be your H plus concentration. I'm going to do a couple of examples on how to calculate the pH of a solution, and then also how to calculate the proton concentration of a solution with a given pH. In order to do this, we're going to need access to a calculator. So here I have a calculator that I'm going to use for this purpose. And the first value is 4.33 times 10 to the minus 5 molar for H plus concentration. We're trying to calculate pH. So there's a couple of ways to do this. One is for a graphing calculator like this. If you have something similar, all you need to do is just do a negative log and then the value of the H plus concentration, which in this case is 4.33 times 10 to the -5. And remember, you need to use that power of 10 button, which could be also an EE button in your calculator. Once you do that, then execute and you get the value of pH. So it's as easy as that. 4.36 is the pH value. Now we can do the next one, which is calculating the H plus concentration if I have a pH value. And the first one is the pH of 2.15. And so to do that, you have to multiply that by -1, which is just -2.15. And then you take 10 to the power of that number. So 10, and then there's usually a power operation like x to the y in this case. So I'll do that. And then it was -2.15 because it's negative of the pH. And then once you execute, you'll get the value of the H plus concentration. You can write it in scientific notation. That would be 7.08 times 10 to the minus 3. There will be examples of how you can calculate both pH or H plus concentration using your calculator.